Let me start. Please mute yourself, okay? Otherwise, that sound will come here in the recording and it will be distracting for you only. Okay. So this is nothing. This was I was just doing the storage automation. I'll minimize this window. This is storage automation I was doing. Okay. So storage basic. So the session is being recorded. Okay, no issues. I mean, it's yes. So today we'll talk about storage basics. Okay. So the storage are different kind of storages are there. One is DAS. DAS means direct attached storage. Okay. Direct attached storage means suppose you have some some server and you have the storage that is attached to the server, okay, directly attached. So that is DAS, okay, which we used to use long ago. Normally we don't use DAS that much, okay. And then we have SAN. Okay, one second, just give me 1 second.
Geyser.
I will teach you. So now we'll talk about SAN. What is SAN? SAN, the full form SAN is, everybody knows, storage area network. Okay, storage area network. Suppose an application requires high performance storage. Okay, it requires high performance storage. Then they will most likely look for solutions in SAN. Okay. So in SAN, what are the components you have? For the SAN, in any storage, what are the components you have? You have front-end ports, you have back-end ports, cache, SAN switches. Okay, so these are the things you have. So basically what would be done, for this is, 1 second, go here, SAN storage images, 1 second. Okay, let me take one image to tell you understand, to make you understand. So in a SAN, okay, so here this is the architecture of SAN. This is the generalized architecture of SAN. Okay, for the NetApp I will teach you in different way. NetApp architecture also I will explain, but first I'm explaining the storage basics. So for the SAN, what you do, it's very easy. You have the components. So initially what you need to do, you need to purchase switches, SAN switches. It can be either Cisco or Brocade. And then what you do, you connect the HBA, the server HBA to the SAN switch. Okay, and most likely you need to use dual HBA because you do not want any like any kind of bad scenario. Okay, you want redundancy. Okay, you don't want any single point of failure. So what you do, you have two HBAs, you connect the HBA with SAN switch. Okay, and you connect the front end port. The storage will have two kind of ports. One is front end port. The front end ports are the ports that is used. The front end port can be your FC ports. If you want SAN, then use FC ports. Okay, and you can also use iSCSI also. So let me talk about FC. So these are the FC ports which you're connecting to the SAN switch, and you're connecting the HBA to the SAN switch. Okay, and then what you are doing zoning. Basically zoning out of two types, hard zoning and soft zoning. Normally you'll be using soft zoning. Soft zoning is nothing but you take the WWPN number of your HBA and WWPN number of front end port and you zone them together. WWPN number is worldwide port name. It's a 16-digit name number that is like unique number. Okay, and sometimes you'll get duplicate WWPN issues also in the ESX, but that is manageable, that you can fix it. But normally WWPN number is a unique number. So what you do, you create the zoning between this. And why do you create the zoning? You create on SAN switch. Okay, I'll show you everything, don't worry. I'll tell you zoning and all these things. Okay, so just about this, so that's what you do. So what you are doing here, these are the storage component. think of it as NetApp. So there are two nodes there, NetApp node 1, node 2, these are in cluster, okay, these are connected, is one cluster, and node 1 from one IPC port of node 1 you are connecting to SAN switch, another IPC port connecting here, there are four paths, okay, and you're doing zoning, okay, this is for IPC, okay, but if you're having iSCSI, right, then what you do, your in SAN you can have two protocols. One is IPC, another is iSCSI. Okay, SCSI, iSCSI. Okay, IPC and iSCSI. Somebody is pinging me. So IPC and iSCSI. See, it's not. He is having some internet issues. That's why I'm not able to admit him. So IPC and iSCSI, okay. So for IPC, what you require? You require fiber channel, you require fiber cables, you require fiber channel switches, which is SAN switches. It can be either Brocade or Cisco. You require HBA, server HBS, okay. You need to zone the WLPN of server HBA with your WLPN number of storage front-end port, okay. Please mute yourself, okay. Okay, so that's what you require, okay. And normally when an application is looking for high performance, you look for IPC, and IPC you require SAN switches, but you have iSCSI, right? For iSCSI you do not require SAN switches. What you require? You require Ethernet switches or LAN switches. So what you do is, for iSCSI, one second, for iSCSI what you do, let me just show the picture, okay. iSCSI storage, okay, just let me show you this. It will be very easy to understand. It's a better picture, yeah. So this is your server, I mean, so this is storage. So what you require in the storage, you will have Ethernet ports, okay, and your server will have NICs. So what you connect? You connect the Ethernet port, you use the copper cable, and you connect with your network switch or LAN switch, and the network switch is managed by your network team, not storage team, okay, and you connect the server NIC with your network switch, and that's how the configuration. So iSCSI, although it's a SAN product, so here what is doing, IP to FC conversion is been going on. So it's like your FC, right? If not FC, sorry, block storage, right? The block is going to the block to IP conversion is going on, okay, and then at destination and again IP to block conversations, okay. But here the data is being transferred, the frames are being transferred using Ethernet switches through copper cables. So this is less expensive compared to buying SAN switches, which requires FC cables. FC cable is much more costlier than copper cables, okay. Speed is also better, and also loss transmission, FC also, it's better capturing the losses, like you do not have that much loss of signals, okay. So here what you're doing in iSCSI, we're not using network switch. So suppose you have a client, they don't want to purchase SAN switches, they don't want to spend money, then what they can do, they can just use the existing infrastructure. In every project, every company, they will have their local network, local area network, LAN switches, Ethernet switches. So you can use those switches for your iSCSI configurations. You do not need to purchase anything, any more products, okay. But the performance will be much slower compared to FC. FC is much better, okay. FC is much better, okay. So I'll tell you how to configure, SAN using FC protocol, using iSCSI, everything. But initially I'm trying to tell you the basic things, so you can understand the differentiation. Because whenever some person is less than 5 or 6 years experience, right, or if the interviewer wants to ask you basic questions, so they will ask you about this, the difference between this protocol, that protocol. They'll ask you a lot of questions, okay. They'll ask you a lot of questions, okay. So what we are doing here, we are actually using server HBA, okay. So we are actually connecting the server HBA with the SAN switches, okay, and we are also connecting the front end port to the SAN switches, and we are doing zoning. That's what we are doing. And what is the backend ports? The backend ports is nothing but the ports on the backend, okay. What they do, they connect the disks, okay. They are used to connect the disks, okay. They are used to connect the disk. And what is cache? When a user write comes, right, suppose the user you already have given the storage to user, zoning is done, storage allocation is done, okay. The user is trying to write some data on storage, right? The first thing it will do, it will try to write the data on cache. Cache is like, you have the that random access memory RAM, right, in your laptop. So it kind of like same thing. It's a non-volatile memory. So what it does is, it is very fast, okay. So if a user is trying to write the data on the storage, and it is able to write the data on cache, then the writing will be very fast. And so that's called cache write heat, okay. And suppose the user is trying to read some data from the storage, okay, then first it will look for the data from in the cache only, okay. And what it will do, if the data is in cache, then what it will do, it will become a read hit, okay, and data will be given from the cache. So response time will be much better. Response time means what? Response time is how fast application is, suppose application is requesting some data from storage, and it gets this data within 5 milliseconds. So the response time is 5 milliseconds. There is a concept of service time and response time. I will tell you about all these things in detail when I talk about performance analysis, how to troubleshoot the bottleneck, okay, performance bottleneck. So response time means how fast the storage is giving the response to the host or the application. Always you have to 5 millisecond is what always the best practice is 5 millisecond, okay. But the thing is, if you are using NAS, right, so obviously response time will be slower, okay. And the service time is what? Service time, it's includes response time plus your response time of storage, okay, storage, okay. সব লাইট যাতে বারণ করে পাওয়া আমাকে বুঝলো তো, না সব বন্ধ হয়ে যাবে, বুঝলে তো কি বলতে চাইছি? সব দিকে ফ্যানটা বন্ধ করো, নাহলে এটা বন্ধ হয়ে যাবে, ইনভার্টারটা বন্ধ হয়ে যাবে। ফ্যানটা বন্ধ করো, সবগুলো চালিয়ে ইনভার্টারটা বন্ধ হয়ে যাবে, ইনভার্টার লোড টানতে পারবে না, ঠিক আছে। So response time is what? Sorry, service time is what? Response time of storage plus, it's not only storage, okay. In the SAN environment, right, FC environment, you have SAN switches. So SAN switch is also doing something. So data from storage, it is also like data from storage, it is going to your SAN switch, and the SAN switch is not like one SAN switch, okay. It's a fabric. So you have a concept of fabric. Fabric means collection of SAN switches. So normally in any environment you have two fabrics, like fabric A, you can call it some other fabric name also, fabric A and fabric B, okay. Fabric A and fabric B, okay. So what happened is, so as I told you here, right, 1 second, now let me go here, just 1 second. I wanted to show you this thing differently here, okay. You can see here this is a fabric A, this will be collection of switches. So normally what you will have core edge fabric, okay, core edge fabric, okay. You will have core edge fabric. What does it mean? It means core means middle of the portion, middle of the architecture, okay. In the middle there will be core switches, which will be expensive switches. These are called as director switches, okay. And these are having like blades, CP1 CP2 blades will be there. They will be in standby mode. And it will be like, if some ports are like, if some ports are suppose are faulty, right, suppose the management port is faulty, then it will have redundant management ports, actually you can replace them. But if you have fixed port switches, okay, so the redirector switches will be at the core of the architecture, core end of your switches. Core means the middle portion, and the fixed port switches. And please mute yourself, okay? Please have some. Everybody is mute only, okay?
Supriya,
Hello.
నేను కూడా బయట క్లాస్ జాయిన్ అవ్వాలి అందులో లేకుండా
ఇప్పుడేనా క్లాసు
8:30
ఏంటంటే టైం
8:59 ఒక 10 minutes లో
Please mute this guy.
అనుకుంటారా
Okay. So fixed port switches, okay? So what we'll do? Fixed port switches are switches which are like less expensive switches, okay? So you'll have some like 90 ports or something. You can only use those 90 ports, and in fixed port switches you'll have only one management port. What is this management port? In order to access or manage the SAN switch remotely, your SAN switch has to be on the network, okay? SAN switch has to be on the network. And to have the SAN switch on the network, what you have to do? You have to connect the management port of your SAN switch to your network switches, okay? And if the management port is faulty in fixed port switches, then you have to replace the entire switch. There is no other choice, there is no other alternative option available, okay? So in core edge fabric, what you will have? You have the director switches, core switches at the core, middle, and the edge switches at the edge, okay? Modular like fixed port switches. And in the core switches, you will connect the storage front end ports, okay? Physically connect the storage front end ports. And edge switches will connect the servers, okay? And then you will do zoning from them, zoning between them, okay? So what happens is, if server is asking for storage, right? So response time will be given from storage, okay? And then the data is moving from storage, one switch to other switch, okay? So that time is also there, okay? That is time between switches, time in switches also there, okay? That is also there, okay? And also application, like application response, like how fast the application is responding, application, okay? And also server response, okay? So all these things are made of service time, okay? But as a storage admin, we're only concerned about these two things. We're not concerned about application and server. So if somebody is asking, there is performance issues, right? So you have to check the response time of storage. IOPS throughput, I will explain everything to you, okay? And you have to check whether you have any BB credit issues or not in switches, any port errors, any CRC errors. I'll tell you about these things, okay? All these things I'll tell you, okay? So these things is, this thing is like very easy, okay? So one by one you have to understand. So for FC, what you do? One second, let me drink some water. For FC, what you do? You use SAN switches, and you should have a redundant configuration like this. Redundant means, see, two fabrics are there. If one fabric is gone, no issues. The server can access the storage from another fabric, okay? If one of the storage node is down, no issues. The another node is there to take over all these resources. If one of the HB is down, no issues. Another HB is there, okay? And sometimes we'll have server cluster also, like MySQL cluster, Oracle cluster, or ESX cluster. In that case, if one of the ESX server is down, ESX host is down, no issues. You have another ESX host, okay? So we are getting the redundancy on the server end. We are getting the redundancy on fabric end. We are getting the redundancy on storage end, okay? So these are the redundancy we are getting, and redundancy is very important in storage environment. So I'm talking about the redundancy on FC, okay? FC. These things I will talk in detail.
The picture you showed is which one, Dayan? Explain. It is director or core edge switches.
What are you saying?
The picture, whatever you showed, is for core edges, core edge fabric, or director switches.
It's just a generalized picture, okay? In this small box, right, there will be hundreds of things. It's just a generalized picture, okay? like suppose you want to go for the core edge fabric, right? So every environment, most of the time it will be core edge, most of the time. Okay, you go the core edge fabric. Okay, so this is your core edge fabric. Okay, this picture is not good. Let me do it here. Okay, this is the problem. People has to join at same time, bro. I don't really like this. So anyway, this is the core edge fabric. Okay, you can see here. These are the FC director switches. These dual switches, and these are edge switches. These are like fixed port switches, edged here. So you have the server connected to the edge switches, and you have the storage connected to the core switches. You understand, right? What I'm trying to say?
Yes, yes.
Yeah, and how do you connect one switch to another switch? Using ISL connections. I'll tell you different kind of ports in switches. I'll tell you everything. Okay, so you will have E ports here, E ports, extender ports, and you will connect this. Okay, whenever you are connecting one switch with another switch using FC cables, the port will automatically identify itself as E ports. Okay, you don't have to do any special thing. Okay, but you need to have FC ports. You need to have ports which has licenses. There is a concept of ports on demand license, that dynamic ports on demand or normal ports on demand. So ports on demand means your port is having license to use for FC. Okay, and you'll need to purchase licenses for them, and whatever ports is having licenses, only those ports you can use. You need to have license for the FC port, and you need to also install SAP. You need to install SAP, okay, which is a hot pluggable entity. You need to use them. Once SAP is there and you have the license, that switch port you can only use for your connecting either the storage or the server. Okay, you can use for the SAN architecture. Okay, in the SAN environment. If you do not have the ports on demand license for that particular port, you have to look for some other port where you have the license. Okay, where you have the license. So this is very easy, bro. This is very easy. And please check my earlier sessions also, because there are a lot of things I teach. Okay. So you have FC in SAN. You have FC. Okay. You have iSCSI. FC uses SAN switches. iSCSI uses network or LAN switches. FC is much better performance. iSCSI is not that good, but iSCSI is inexpensive. Okay. NetApp supports all protocols, bro. All protocols. Okay. And then you have NAS. NAS is nothing but, suppose you want to put the data in a centralized location and you want multiple users to access those data, okay, and you are not concerned about the performance. In that situation you can use NAS. Okay. So normally in ESX environment we can also use NFS data store. Okay, that means you are in a ESX environment, you are creating a data store and you are allocating storage from the data store to multiple VMs. Okay, then what you need to do, you can create NFS. NFS you can create and you can allocate there to the data store. For ESX also you can use NFS. So in NAS there are two protocols, CIFS and NFS. CIFS, the full form of CIFS is Common Internet File System. It was initially created by Microsoft only. Okay, and NFS is Network File System. Okay, so CIFS is used for only Windows servers. Only Windows servers. NFS is for Unix servers. Okay, Unix servers. Okay, so basically what you do is, suppose you want a share and you want to be allocated to multiple Windows servers or Windows host. Okay, and suppose you want the domain users to use those shares and put the files. Okay, so what happens is that you go for CIFS. The first thing about CIFS is, you should, in any storage you should have the CIFS license. Okay, here also license. In NetApp there are three types of license: cluster-wide license, node-based license, and evolution license. I'll talk about all these things when I go into NetApp. Now is the time for the storage basics. Okay, so license is the first thing that we have. Okay, and there are many steps that we need to do. I will tell you this, so just giving the basics. Okay, and NAS, for NAS what you need to do, ফ্যানটা বন্ধ করে দাও না, ফ্যানটা বন্ধ করে দাও। For the NAS লাইটটা ইয়ে করছে, লাইটটা দপদপ করছে, ফ্যানটা বন্ধ করো। For the NAS, what it does, it's like just storage in centralized. দপদপ করছে, এটা টানতে পারছে না, দপদপ করছে এটা লাইটটা। So in NAS, what happens, suppose you want to have a share, okay? You want to use the share as a centralized location, then you use NAS. For CIFS, you use Windows Server. Windows Server you want to use, you use CIFS. And suppose you want to use the NAS storage in Unix servers, you want to mount on a directory, okay? Then you use NFS. Then you use NFS, okay? And for NAS, we do not require to do zoning. We use Ethernet or LAN switches. So here what we do in FC, what we did in FC, we used Ethernet. Sorry, we used FC ports of NetApp nodes. Okay, ports use of storage. Okay, in iSCSI we used Ethernet ports. Okay, of storage, and in NAS we'll use Ethernet ports. Okay, of storage. So that's what we'll do. Okay, so in FC only we need to do zoning. We don't need to do zoning in iSCSI, and we don't require to do zoning in NAS. So the first thing, normally the interview will ask the basic difference between SAN and NAS. You can tell them zoning is required, zoning is not required. FC switches, Ethernet switches, you can tell. Then they can grill you on saying this. What about iSCSI? You can tell them iSCSI uses LAN switches or network switches. It does not use FC switches. Okay, that's what you can tell them. Okay. And here the cache is very important part, as I said, cache. So whenever the data is being requested, data is being asked, some user wants to access the data from storage. If it's on the cache, then the cache, from the cache will be, the data will be moved to the front end port, and from there front end port will move the data to the server. Okay, so the response time is much faster. But in any case, the data is not in cache, it's on disk. So what would happen? So when the server or the application is requesting the data, it will first be moved from the disk to cache, and then from the cache to front end port, and from the front end port to server. Moving the data from disk to cache is called as staging process. Because of this staging process, it takes more time. Normally 4 times it will take, means suppose it's taking only 5 milliseconds if the data is on cache. Okay, then when the data has to be staged from the disk, when the data is not in cache, it will take 4 into 5, 20 milliseconds. So the response time will be much slower. Application will not, if the application wants 5 millisecond response time to work, then it will face latency issues. Latency, bottleneck, these are all synonyms in storage for performance issues. They all denote performance issues. Okay, let me go into this. And yeah, so obviously you need to have license. For iSCSI also you need to have license. Okay, and for NAS, what you are doing, again the server, the NIC card you are adding. Okay, NIC. And nowadays you have one thing, converged adapter, okay, which supports both HBA and NIC. Both this thing will be there in converged adapter. You can purchase the converged adapter for the server. It will be on the server end. Okay, it will be on the server end. Okay, and what you need to do, suppose you want to do FC, then you connect the HBA to your fabric. Okay, and suppose you want to do iSCSI, then you connect the NIC with the LAN switches. You want the NAS, you connect the NIC with the LAN switches. Okay, that's what you do. So FC required LAN switches, NAS or iSCSI required LAN switches, Ethernet switches, and 99% of the time the Ethernet switches management will be done by your network team, not by storage team. Okay, please somebody tell Madhav. Okay, we are trying to accept him, but what is happening? Sitaram is still meeting ID. Is a problem, right? What? Madhava, you are there, right? Madhava? No, it's not there. I think he has some issues with the internet. Okay, that's why he's not able to log in. Because my internet is good. I'm using 40 Mbps, not 40, 100 Mbps Airtel. Okay, I'm using it, so I do not have any issues. Okay. So what I'm telling you, that you have to understand whatever the things I told you, right? You have to understand fabric. They'll ask you what is fabric, collection of switches, core edge fabric, full mesh, partial mesh, that you don't have to know. They'll ask you about ISLs. Okay. So ISL is something when you in a fabric, right? You are connecting your core switches to the edge switches, right? Then you use ISL. Okay. Then what you do, you connect the FC cable from to one switch to another switch, and this connection is named as ISL. These are physical ISL, and there is a virtual ISL also. Suppose you have a switch, okay, and your customer wants that. Suppose you have two different customer, like Friends Life Diligenta. I'm just giving an example which I work for, okay. And then what you need to do, you want to do logical segregation of your storage or SAN switches. Then for the switches, for the I'm talking about for the brokered SAN switches, right? What you do, you create virtual fabric. Okay, in virtual fabric what you do, initially all the ports will belong to the base switch, default switch. Okay, you have to move those switches, sorry, move those ports from the default switch to the, you have to move those ports default switch to the virtual fabric. Okay, so suppose you have a Friends Life and Diligenta, two different projects, then you can create one virtual fabric for Friends Life, one virtual fabric for Diligenta in a same switch. And whatever fabric ID you are giving, right? So fabric ID you are giving 21 and 22. Then you have to do the same thing in the other switch. So between this fabric ID, right? Fabric ID of switch 1 and the fabric ID of switch 2 will be same, and there will be, like, suppose you are doing a physical ISL connection, right? The virtual ISL connection will be done between them. Okay, virtual ISL. Okay, virtual ISL, logical ISL. Logical ISL is the better term. LISL. Okay, I told all about these things in my previous sessions. So 10 session I took for the storage basics. Okay, logical ISL, logical ISL will do. Okay, normally they don't ask you about this, but I'm trying to give you informations. Okay, sometimes it might be useful for you during your project work also. We don't know what kind of work you are having. One of the persons from Netherlands, he took me training from the SAN switch advanced training. Okay, so that I helped him to create these things. Okay, and many more things. Okay, so it is very easy. The main thing you have to understand, there are two types of switches, director switches and fixed port switches. Director switches will come in CPU and CPU2 architecture. It will have two management ports, and management ports are used for the SAN switches to be on network, so we can use it remotely, we can manage them remotely. We do not have to go to the data center and connect on the serial port to manage the switch. Okay, we can connect from anywhere. Okay, where you have the management connect, like network connection, we can do that. Okay, so you have to understand that different kind of switches are there, brokered, like director switches, fixed port switches. I'll also talk about zoning, switch upgrade, port area troubleshooting, all these things I'll tell you. Not switch installation, okay? But I have also uploaded one switch installation, you can check there, okay? Because if I give training like this, it will never end, okay? So I'm trying to give you the basic, just try to go through this and try to understand what I'm trying to tell, okay? So SAN switches are there, let me think, yeah. And there will be, there will be another protocol also, like object storage. Okay, object storage. So what happens in object storage? Suppose you have your storage in California and you have in India. Okay, object storage, you can use the data in geopolitical or geo separated locations. Okay, object storage, different countries. Okay, object storage is like very different. Initially it was done by the Amazon only, and in object storage the protocol they use is called as S3. S3 means three S's, simple storage service. Its name is simple storage and service. Okay, so here in object storage what you do is very easy. NetApp supports all protocols. Okay, NetApp supports FC, iSCSI, CIFS, NFS, S3, okay, NVMe, NVMe was all teach, okay. So all these protocols are supported. And NetApp is also having another product of object storage which is called as storage grid. There's a specialized product. So normally what we do, in object storage, we suppose you want to put the data in object storage, you can do that. And in some environment, okay, what we do is, in some project or assignment, what we do is, we use the object storage to keep our target data. Target data means in something, some projects you'll have replication configured. Replication means what? You have a storage at your production, you have the arrays in your production, array means storage boxes, and you also have a disaster recovery side. In your production, if when your production is down, you want the application to be running from the disaster recovery side. Production can be down due to some earthquake, flood, any natural calamities, or it can be due to power failure, network failure, okay, lot of different things could be there. But you do not want your application to be down, you do not want your production to be down. So what you do, you have two separate environment, one is production, one is DR, and you create replication between them. Replication means the data is constantly being replicated, is constantly being copied to the DR, okay, is constantly being replicated to the DR, okay. So you have your production volume, you have your DR volume, you have the DR volume. So sometimes what you do, we keep the DR data, we keep the data which is a DR, right, on the object storage. This is called as tiering, and we use flash pool technology for that, okay. We use flash pool technology for that, okay. In NetApp we use flash pool technology for that, okay. I will tell you all these things, everything is part of my syllabus, so one by one I'll go through it, okay, not at the same time, okay. Like whatever it's there, right, I will teach you everything theoretically and practically. And this is a lifelong training, so I will give you the training for 10 years, at least 10 years, okay. Because I don't know after 10 years where I'll be, whether I'll be alive or not, I don't know. So for 10 years I'll give you the training, okay. Okay, I'm sorry, here. So I'm just giving you a basic idea, okay. So let's suppose for SAN FC, just give me a basic idea, okay. Normally for FC, what you normally for any storage, what you need to do, I'm not talking about NetApp, any storage, what you do, you have to create a storage pool, okay, storage pool which is made of disk, okay, and you need to define RAID on it, okay. Let me just give you what is RAID. 1 second. RAID is basically redundant, array of inexpensive disk or independent disk, okay, independent disk. Suppose you have a storage pool, you are creating a storage pool using disk, right. Suppose some disk fails, then what would happen? You will lose the data, right. In order to protect the data, this IEEE, I think, so they have invented this RAID, okay, RAID concept back in 1990s, okay. They have invented this concept. Okay, so in what we do in there, we just aggregate different disks, okay, and we have the parity in the disk. So what happens? So if some of the disk fails, right, from the surviving disk and the parity disk, the failed data is recreated, okay, using XOR and XNOR operations. If somebody has studied digital electronics during their bachelor's, then they will understand about XOR and XNOR, okay, but you don't have to know about it, it's easy, okay. So let me tell you about one by one. The first RAID that was invented was RAID 0, okay, RAID 0. It did not have any redundancy at all, okay, RAID 0. So in RAID 0, what we are doing? We are striping the data across multiple disks, okay, A1, A2, A3, A4. So disk fails, data loss is there, but performance is much better because the data is written in it's spread across all the disk, right. So performance is much better, read performance and write performance is much better. But if suppose A1 block is gone, right, we cannot recover because it's not duplicated or the parity is not there, okay. So they used to call it as striping, okay, striping of data, okay. Here showing us two disks, So the blocks is striping like A1, A2, then A3, A4, A5, A6. These are blocks which is striped across the two disc, okay? And it came red one, okay? It came red one, which is like, which they called as mirroring, okay? You can see here, same block is copied twice, right? A1, A1, A2, A2, A3, A3, okay? So here what happens? If this disk is gone, then this mirror disk is there. The data is not lost, but there is a problem, bro. Suppose you are using 100 TB of data, like you have the disk, you aggregated the disk, it's 100 TB of data, but you're using RAID 1, so you lose 50% of the data because the data will be copied, right? So the usable capacity will be 50%, okay? So what does it mean? It is expensive. You are losing half of the capacity to have the mirror. Suppose you are having the SSD disk, right, which is very expensive, then this is not an ideal situation, okay? But sometimes RAID 1 is used, in long, like when I used to work in back in 2011, I have used a lot of RAID 1s. Reason being, I used to use SATA disk, which are like very slow disk, mechanical disk. But nowadays people are reliant on flash disk, which are non-mechanical disk. In mechanical disk, you have the header, seeker, sectors, okay? So whenever the data is there, the header has to locate the data from the sectors, okay? And it will like rotate on the platter. There will be platter, okay, where there will be sectors. But in flash, there is no mechanical thing, okay? Like in flash modules, FMD disk or solid state devices, okay? So there, it's supposed to be very fast, so you do not require, you don't want this RAID on there, okay? Because you'll be losing out 50% of the data just to have the mirror, okay? So this is not good from from price point of view, okay? But here the read is very fast, read is very fast. Whenever data is being read, it can be given from any disk, right? So read is very fast, okay? Then another RAID came, RAID 4. RAID 2, RAID 3 is not used, RAID 4, okay? 1 second. So in RAID 4, what is happening? Let me click on this picture. So here we're using 3D plus 1P, 3D plus 1P, okay? Let me just show you here. RAID 4. In the given example, I'm using 3D plus 1P. They will ask you during the interview, okay? D means data disk, P means parity disk. So 3 data disk and 1 parity disk, okay? 3 data disk and 1 parity disk. So whenever the data is being written, the parity is calculated and it is stored on the parity disk, because this 3D plus 1P means what? We have a one fixed parity. That disk is only to keep the parity blocks, okay? So if one of the disk is lost, right, from the surviving disk and the parity disk, we can regenerate the lost data. But if two disks are gone at the same time simultaneously, then the data is gone. We cannot really recover the data from the RAID group, okay? Because it only protects from the one disk failure, one parity is there, okay? But because it is having fixed parity, right? So if the parity disk is gone, then you have problem, right? But NetApp uses RAID 4. NetApp uses RAID 4, and that is very rare that other storage uses RAID 4. Hitachi does not use RAID 4, okay? NetApp uses RAID 4. But there are good things about RAID 4 also. I will talk about that when I talk about write penalties, okay? And then you have RAID 5. RAID 5, okay? So here 3D plus 1P, that is okay. But here you can see, right, this is also having only one parity, but the parity block is being distributed across all the disk in the RAID group, okay? So parity is distributed, so it does not have to look on the parity disk, okay? It is distributed, so parity is also striped, so that's the performance is much better. Parity is distributed, the performance is, I would not say performance is better, but I would say that the distribution is better, so redundancy is more better, okay? Redundancy is more better, okay? But there is one problem, there is one small problem. What is the more small problem? There is a concept of rate penalty, right penalty. They will ask you during the interviews. So what does it mean? to write a data on a RAID group, how many IOs will be done? IO means input output operations. So you are writing a data, that is IO. You are writing a data on storage, that is IO. You are reading a data from storage, that is IO. Write IO, read IO. Those all be calculated, okay? Suppose, there is an example. Suppose you are trying to write a data on the RAID group, okay? You are trying to write the data on a RAID group, on the RAID 5, okay? What happened? Or suppose you're trying to change the data. First, what happened? Suppose you're trying to change the data a1 to a dash, e1 dash. First, e1 will be read, okay? So there is a read IO, okay? Then e1 will be write, okay? e1 will be changed to a1 dash, that will be write IO, okay? Then the parity will be calculated. There is a read IO. The parity will be read. There is a read IO, and the parity will be written, okay? There is a write IO, okay? So for one IO, for one write operations, you have to do 4 IOs. So the write penalty for RAID 4 is 4, okay? So you are doing 4 IOs, which is not good. But the write penalty for RAID 4 would be 2, okay? RAID 2 1 and 1, yeah. RAID 4 would be 2, okay? Okay, because suppose you are trying to write a data, okay? What it will do? It will read the data, it will calculate the parity, and to write the data, okay? So it will be 2, okay? So that's why the response time is much better, okay? The performance is much improved, okay? But in NetApp only they use RAID 4, okay? So in both in RAID 4 and RAID 5, you are getting the protection against only one disk failure. If one disk fails, you can rejoin the data from the parity disk and the surviving disk, okay? The existing disk. But if more than one disk fails at the same time, then you cannot recover the data from the RAID groups, okay? You lose the RAID group, okay? You lose the data, okay? That's why the disk failures is a very important thing, and it has to be attended immediately, okay? And then you have another RAID group which is called as RAID 6, okay? RAID 6. What happened here? In RAID 6, you will have, like here we have 4D plus 2P, so 2 parity will be calculated, okay? For one block, 2 parity will be calculated, and it will be striped across all the disk in the RAID group. So what would happen? If you lose one of the disk in the RAID group, no issues. If you lose 2 disks at the same time, no issues. So it can protect against 2 disk failure. But again, the write penalty will be 6, okay? Like write penalty will be 6 for RAID 6, because again you have to generate an additional parity you have to generate. So again it will be slower, okay? What does it mean? The write operations, the random and sequential write operations in RAID 5 will be better than RAID 6, and RAID 4 will be better, okay? And RAID 1 is much better. RAID 1 is much better, okay, compared to this. But RAID 1 is not having any redundancy because the data is typed across all the disk, but it does not have any parity, and also it is not copied to another disk like RAID 0, okay? Like mirroring, okay? RAID 0 is called as mirroring, okay? Okay. They will ask you about write penalty also, okay? And then you have another one, okay, which are called as nested RAIDs. Yeah, tell me. Yeah, bro, tell me. Do you have
Yeah,
any
Dayal, if you
questions?
could just
Anybody have?
repeat the parity one. Yeah, about
What
the
is it?
parity once again. Can you just repeat about the parity?
Parity. So parity is basically a block where we do XOR operations of data, XOR, XNOT, and we keep the data. Reason being, if some of the data, if some blocks in a disk or in one of the disk in the RAID group fails, we can use that parity block, and we can use the surviving data, existing data, and we can do some operations, and we can regenerate the failed data. Okay, that's why we use the parity. It is for redundancy purpose, fault tolerance purpose, so that we do not have any single point of failure. Okay, you understand, right?
Yes, that I understood. But when it comes to RAID 4, right, it has 3 data disk and 1 parity disk, correct?
Hmm.
And
Hmm.
what happens if the parity disk itself gets failed?
Yeah, that's the question. If the parity disk is fails, no problem. We have the data. Okay. but
Okay.
we might have issues, we might have performance issues when you try to replace the disk. We definitely will have performance issues when you try to replace the disk. So in a storage array we have spare disk also. So whenever the disk is fails, the spare disk will take care of the failed disk, and the failed disk will be spared. Okay, and whenever you're replacing the disk, the spare will be replaced. Okay, but if spare is not there, okay, so what will happen? The battery disk is failed, and you are again trying to do this, so the RAID will be rebuilt, right? So again the packet will be generated and it will have performance issues. You will get performance issues. Okay, you'll get
Yes.
to when you regenerate the RAID groups. Okay, so that's the
Okay.
problem we'll have in RAID 4. But RAID 4 is better because it does not have to do that many IOPS for one write operations like you do in RAID 5, even though both are only doing one protection, like single disk protection only. Still, RAID 4 is much better. That's why NetApp has adopted RAID 4. RAID 4, okay?
But if I'm not, just correct me. NetApp uses something called as RAID DP, right? RAID dual parity.
I will talk about all these things, bro. Don't worry, okay?
Okay,
RAID
then.
4, RAID DP, RAID TC. They have three RAIDs.
Okay.
RAID
Okay.
4 is also there.
Okay.
So RAID 10 is nested RAIDs. What is nested RAID? RAID 10. So what we are doing here? So we are striping the data. This is type of mirrors. Mirror of stripes. No, this is mirror of stripes. Here you see stripe and then mirror. Okay. For Oracle applications, Oracle database, RAID 10 is the better option. RAID 5 and RAID 0. That's why in Hitachi, from Hitachi, let's rejoin. This is three teams. So after 60 minutes, it gets disconnected. Rejoin. Internet issues.
ಇಷ್ಟೊತ್ತು ಮಾಡ್ತಿದ್ದು ಪಾಪ ಅಕ್ಕ
Let me first let all the join, then I will again begin. 1 second. I hope everybody joined, right? No, this guy is joining. Ankit. Ankit. Who's Ankit? Ankit. Ankit, who is this? Ankit? Ankit? Hello?
Yes, Ankit
Okay.
Sharma.
Yeah, what is your full name, Ankit?
Ankit Sharma.
Ankit Shah. Okay, no problem. Okay. So this is there. I think everybody joined, right? So let us again start. 1 second. This is a free team, so every 16 minutes it will keep on getting disconnected. Okay, you can see with the current plan, but you just have to log in again. Okay. So RAID 10, right? Type of mirror. Okay. So what happened here? What we are doing? Like these are stripe and we are mirroring the stripes. Okay, sorry, mirror. These are mirror, right? RAID 1. So mirror, and we are striping the data. Okay. So this is what
It's
doing in
recording,
RAID
right?
10.
Yeah, it's recording, right? The session.
What is saying?
Is it recording?
Yeah, recording is on. Yeah, you can see here, recording is on. Okay, and then you have another one, RAID 01. Okay, so that is the opposite of that. It is like here we are just doing stripe. Okay, and then stripe of mirrors we are doing. Okay, so normally we'll not use this for NetApp. Normally what? We'll not use it anyway for NetApp. Okay, for NetApp we'll use RAID 4, RAID DP, and RAID TEC. And in NetApp, right, see, RAID 6 is having write penalty of 6, but RAID DP will have write penalty of 2. Okay, that's why RAID DP is much better. The performance is much better. Okay, by default, whenever you are creating an aggregate like storage pool in others, In other storages, the pool that aggregate, like when you amalgamate or you just group the disk together and you try to create something, then you call them storage pool. Okay, in NetApp it is called as aggregates. In NetApp it is called as aggregates. And whenever you are creating aggregate, you have to define the how many disks you want to use. You have to define the RAID type. If you do not define any RAID type, by default it will take RAID DP. Otherwise you can do either RAID 4 and go with RAID TEC. So RAID DP. So you can see the RAID TP here. Okay, so here in RAID TP you will have two parities, but the parities are like there will be two parities. Okay, diagonal parity and sequential parity. There will be two parities. You don't have to know about that, but basically RAID TP is a little bit different. Okay, compared to RAID TP is different compared to your RAID 6. Okay, because in RAID DP what happens, you will have the fixed parity. Okay, instead of distributed parity you'll have fixed parity, but in different way, diagonal and this one. Okay, so that you'll have. Okay, and then you have RAID TEC. Okay, so RAID DP will help you to protect against two simultaneous disk failure. Okay, and RAID TEC will protect against three disk failures. I don't know why the picture is not coming for RAID TEC, but anyway, so basically RAID TEC will be like three. Picture is not coming, but anyway I can only show you from the picture. Okay, so RAID TEC picture is not there unfortunately. But here you can do, here you can just, this is just something it's showing is for NetApp. Okay, you're using this RAID TEC, RAID DP, RAID 4. Okay, so RAID TEC is like you'll have three disk, like three disk of parity. So what happened is, so if RAID DP is RAID 6. Okay, RAID DP, right? So RAID DP will be like, suppose you're using this like 3D plus 2P. Okay, this is RAID D. So you're losing out of 5 disks, you're losing 3 disks, 2 disks to parity. Okay, and if you're using RAID TEC, then it will be like this, 3D plus 3P. So you're losing 3 disks to parity. Okay, so here it will protect against 3 simultaneous disk failures. It will protect against 2 disk failures, 2 simultaneous disk failures, and this is you are losing out, if for every 6 disks you're losing out 3 disks to parity. Okay, so the capacity, the cost will be more if you're using RAID TEC. If you're using RAID 4, the cost will be very less. Okay, and by default whenever you are creating an aggregate, whenever you're creating a storage pool in NetApp, it will take the RAID DP. Okay, so today we'll stop the session here. Guys, do you have any questions before we wrap up for today? Please let me know if you have any questions. Okay, let me know if you have any questions. Yeah, Aishwarya, please let me know.
What is difference having a diagonal parity and having a one parity disk? What does
Not
it
about
make a
diagonal parity.
difference?
I will tell you one thing: single parity and distributed parity. Okay, single parity is like if you lose the single parity, right, you have to rebuild that RAID group. Okay, it will it'll give you performance issues. But if you are having like distributed parity, then it's better. But another problem is that if you're having the distributed parity, right, then the write penalty will be more. Write penalty will be more. That means for one IO, one write IO, you have to do lot of IOs. So that will make it slower. The response time will be slower. Okay, but if your write penalty is less in terms of fixed parity that you use in RAID DP and RAID TEC, then what would happen? The response will be much better. Okay, this will be much better. I cannot talk about that much, sequential and diagonal parity. I have to check about this thing, but nobody will ask you about what kind of different kind of parity is there in RAID DP. But I have to check about that. I have to read about it. Okay, but this is normally they will
Okay.
ask. Yeah, and
So
please
you
check
will
one of
be,
the sessions. Yeah.
sir, you can go. Continue.
Yeah, please check one of the sessions where I've shown you how to calculate. Like suppose you have some disk and the disk is suppose SATA disk, SAS disk, this is disk, and it will have some IOs, right? How to calculate how much IOPS will be generated or supported by that particular aggregate. Okay, that formula, that calculation I have shown. Okay, they will not ask you this, but just for the better purpose, you can check that session. Okay, I've just given that calculations. Okay, and any more questions
Very
from any? Yeah, it's in the playlist only. Okay, you will not get the playlist, but anyway, so other people I'm talking about. So you have to do the payment, right? Then
Mhm.
only yeah. This is the first class, yeah. So anyway,
So
so other
you
people
will not
you
be
can
explaining that again, or we need to go through that, and then if we have any doubt on that.
yeah, if you have any doubt, you can ask because the thing is, uh, there are many sessions I have done in the previous class, but here I want to consider more on NetApp. Okay, the in last batch, right? I have taken 8 sessions, 7 to 8 sessions only on storage basics, but that is not actually required. Okay, for 3 to 4 sessions is enough for storage basics. Okay, because you will be able to understand the grasp of storage basics. Okay, but there I just I got into very depth of storage basics in last batch, but that was not really required. Okay,
Okay.
yeah. So anybody have any questions before we wrap up for today?
Yeah, I have joined bit late. This session also will be uploaded on the YouTube.
Yes, both in L2 and L3 session. Okay, L3 channel.
Yeah.
I probably have to give access to 2 more candidates we just joined recently, Adnan and another 1 or 2 candidates. So I'll give you the access right away, okay, on respective things, and you'll get an email. You just have to click on that email. And if you have any issues, you can talk to any of the students. They will help you, okay? It's just very easy. You'll get the read-only access of that particular channel. For L2, I have a channel. L3, I have a channel. Hitachi, I have a channel. Storage automation, I have a channel. And I just keep on uploading the sessions, all sessions there, okay? So you can just read from it, okay? Any more questions you have before we
Yeah,
wrap up?
what are front end and back end actually? It's bit confusing. That
Yeah. Let me show you using the diagram. 1 second. I want to see the picture. That's the reason, I just used this. Yes, this is a very good picture. So this is your storage system. Intelligent storage system is external storage system, not DAS. Okay. So you have the front end ports. In the front end ports, what you are doing, you have the host. This is a SAN switch. You're connecting the front end ports to your SAN switch. You're connecting the host to your SAN switch, and you are doing zoning between them. And now you can allocate storage to your host. Okay. You can allocate to your host. And then one more thing is there. Suppose you want to replicate from one storage to another storage, then what you do, you zone the front end port of your production array with, and with the WLPN of your, use the WLPN, like you connect the front end port of your production to your SAN switch, and you connect the front end port of your DR array to SAN switch, and you zone between them. Okay, you zone the WLPN between them. Okay, that's what you do. So front end port is used for replication purpose. It is used for host connectivity. Okay, but this is backend. What is backend? Backend is to connect the disk. Okay, so what normally it will have? It will have a SAS cable, SAS expander, and daisy chaining. So your backend ports, like you have the disk, right? So one disk in, sorry, one disk out will be going to the another disk in. Okay, daisy chaining will be there. Okay, so what happened? Suppose user is I requesting the data, so from the HBA it will go to the front end port. Front end port will have some processor. In Hitachi it have the Xeon processor. In NetApp it will have some other processor. So it will look for the data in cache. If the data is in cache, it will take the cache. It will do the data movement operation to the HB. Okay, from the switch, first switch, and then from the switch to the HB. Okay, I mean host. Okay, so it is doing the data movement operation, and in any case the data is not in cache, what it will do, the front end port will let the back end port know, and the back end port will have some processor. It will take the data from the disk. It will keep the data in the, it will stage the data in cache. From cache the front end port will give the data to the frames, fabrics, and from the fabric to the host. Okay, so it is doing, okay, you understand, right? The process, backend port is to connect the disk, front end port is to connect the host connectivity or for the replication. Okay, now is it clear?
yes, there. This is called staging. You told
What are you saying?
this is called staging. You told
Staging, 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 destaging. So destaging is what? Suppose you have the data on cache, and the data which is in cache is not, the user is not requesting for the data. Okay, so it has become cold data. So once the data has become cold data, it will be moved to the disk, physical disk. It is called destaging. Destaging. Okay, destaging. Okay, staging, destaging. Staging is here, and destaging is here. Okay, staging and destaging. They might ask you this. Okay.
Okay, thanks, Dayan.
Yeah, so this is the main thing actually. People do not understand storage only because of they do not understand this thing. Only this part will help them to understand SAN. I understood this back in 2012 or 2011, I think. There was one data center guy who taught me this thing, and my mentor is Brett Daly, who's having like 65 years of old. I met him in Cognizant. Okay, he's still there. Not in Cognizant, he works in Amex. But anyway, so some people are having a lot of knowledge, bro. So I am having two mentors. One is Brett Daly and another is Sukhendra Roy. So both reside in USA, and they have like 39 years of experience on storage. Okay, storage and everything. So basically, what you need to do, you have to make friends, and in order that you want to get referred to some companies, right? To reach out, feel free to reach out to me, and have you referred to at least 30 companies. Okay, by all my students. Okay, Hitachi, NetApp, Daily EMC, I think I do not have anyone, and all MNC companies and all other small startup also. Okay, different companies. Okay, Kindle and all, TCS, Accenture, Wipro, Capgemini, everything. So I can refer you guys. Okay, but once you're prepared, okay, and I'll also do mock interviews for you guys once you are prepared. So I'll give you a lot of knowledge. You just have to understand. And one more thing you have to understand, bro. The thing that you have to understand is you have to go to my course, okay? Not the Learn Infra channel, okay? Do not go to the Learn Infra channel, okay? It's not required. You go to this channel. This is for the L2 sessions. So go this channel. Go to the videos. I don't know why it's not coming. But anyway, so go here, okay, and here you will be able to see all these sessions. Okay, you just read through all these sessions. I mean, obviously I'll give you, but if somebody wants to read ahead, okay, then this is the recently I uploaded this. Okay, so you can see the troubleshooting, replications, non-disruptive operations, revert. Okay, you can go through all these sessions for the L2, and for the L3 it will be a little bit tricky for the L3. Okay, let me go here. I hope it's the same thing. 1 second. I don't know why it's not coming. 1 second. Let me go to the channel. Review channel. Okay, let me go to the list. This is the storage basis that I have uploaded separately. For L2 also I will upload this. 9 videos are there. Okay, but I will give you the storage basis live. Don't worry about that. Okay, I will tell you everything that you need to know. So here you can go through these sessions. Okay, and mostly just consider on troubleshooting sessions for for interview purpose and also for the project purpose. So everything CVO also, cloud volume OneTap, which is a NetApp offering, that is NetApp has used NetApp created using cloud. So you can run the NetApp commands in the cloud also, like Snapper, everything you can do. NetApp commands will work in cloud. Okay, so for that this product is there. So everything I've done. This is for 7 mode to C mode migration, business country replications, everything metro cluster. So all the things there. Few sessions that I was not able to do in the last session, I will do here, like Snap Center, a policy snap log. These are the optional sessions I was not able to do, and also I was not able to do encryption. Okay, so I will do this in this session. Okay, so don't worry about it. Everything will be there. Okay, and just try, keep on learning. And if you have any questions, you can reach out to me. And this will be like every year I will conduct like 4 batches. Okay, 4 into 3. So you can repeat 4 times in a year. Okay, and it will go on and on. Okay, so don't worry about that. And whatever, and suppose you some topic you need some knowledge on some topic, right, which is not mentioned here. What I will do, I will add it to the next page and I'll give it to you. Okay, It does not matter what topic it is. But yeah, L2 is limited. Whatever L2 people, I'm giving L2, I'm talking about L3 because L2, if L2 is asking that to give the L3 topic at there, it's not possible. But L2 is like whatever I'm giving you, right? It is enough for an L2 job. You can easily clear. 6 to 7 years job, even 8 years also you can easily clear using this, okay? But when you are having more than 10, then you need this. You need to have more knowledge, okay? So these are all practical experience. Yeah, today also I did one troubleshooting. Okay, so I was struggling with GAD, which is a Hitachi product, like last week, but eventually did it. But anyway, so and also in my node I have the automations, but I'm using Ansible and Python to automate NetApp and Hitachi. Hitachi I'm using only Ansible. Okay, so anyway, so what I'm asking you, just read, just try to read all my sessions that I'm given access to, and just continue, just be attentive to sessions and ask, free feel to ask any questions. It can, no question is silly, because the question, more question you ask, more I can understand than whether you are able to understand or not, okay? And I can probably guide you that you need to read this, you have to check this session, okay? And most of my students are NCTA certified, but it's not about like they took my training and there's a certification. Even before my training also somebody did certification, which is very easy, okay? You can and you can talk to them. I also have many leads also, different companies like Kindle and all, okay? Like 15 years experience people also there, okay? So just go through that. So here you can see, right, cloud tiering is what? So data, the snapshot data, or the data which is at the replicated data, right, I'm putting on the lower performance disk, okay? Cloud tiers, I have either storage grid or Alibaba storage, AWS, Azure, I'm moving it there, okay? Cloud Insight is a tool for to understand if you have some storage issues in environment or application issues, to understand why the issue is. It can analyze network, it can analyze VMware, storage, everything. So that's, now we call the name as DII, okay? Recent session that I've given. This session I don't give anymore because nobody uses E-series. Only one time I have created this session, E-series, okay? And all these things will be there, balancing algorithm, everything will be there, okay? I will teach you all the thing one by one. So have patience and you will learn everything, okay? So we'll have the same, we'll have the session same time tomorrow. Right now we have storm here, but thankfully I have the power backup, like inverter, so that's why I have no issues. But right now it's raining heavily and also storm is there, okay? So because it's a summer season, right? Kal Boisakhi is there. So anyway, so just read through all these things, and anybody wants referral, let me know. I can have you guys refer to at least 30 companies, okay? Let me know if anybody wants referral, okay? So thank you so much all. Please join tomorrow at same time, 8 o'clock. I'll share the session link there, okay? And the people who are having trouble to join, right? You please check your internet. You probably have internet issues, okay? Because I do not have any issues in internet, okay? Okay, well, so I'll stop.